I'm Steve. I am head of software at ITDev. I've come straight out of uni, started at ITDev, been there, I think this is my 11th year now. So I kind of worked my way up from software engineer, senior, head of software. So my view of CI is very much what ITDev are doing. So I kind of haven't been exposed that much to what other companies are doing, so I'm very interested to see what people are doing. So first of all, CI and ITDev, kind of where do we use it? Obviously software engineering department, which I'm managing. We use it internally for our client portal, which Jono mentioned, which is kind of our track system. So we kind of have builds of that, and we deploy that and test it, and then kind of switch out the live production system. So we use CI for that. We have some product development going on, and that's the key part of that is it has a core algorithm, and we use CI to kind of track performance metrics, just to see that we're on the right line, we're not making it worse, we're always making it better. And then client projects. So as a design services company, we work on lots of client projects, and we always try and use CI in them. Mainly we're just kind of doing static code analysis, documentation, unit testing, build. So at the end of our kind of CI is producing a build. So we're not so much deploying it then onto hardware or anything like that. We're just kind of, this is our release build, and then you go away and test it afterwards. Electronic engineering, we've started using that on client projects as well. Again, we're doing like static code analysis using Blue Pearl software, simulations for verification, and then actual builds of FPGAs with kind of timing reports, making sure everything's working as expected. And again, the result of that is a binary file that's built, ready to go onto an FPGA. So CI tools that we use in ITDev, we're very much using kind of open source tools, free and open source. So we've got Jenkins is the core tool that we use. And then that links into Subversion and Git, which we use for our revision control. Depending on the client, they will either request one or the other. I think as a company, we kind of originally started on Subversion. We've shifted to Git as a preference now. And then we also use Review Board for kind of peer review, and we kind of bake that all in to our CI system. And then we've got developers and reviewers on the side. Unfortunately, they're not free. We haven't found any yet so far, but so yeah, that's us. That's kind of the tools that we use. So CI challenges. So we've had some challenges over the years in our CI. Some of them we've resolved, and I'll discuss these in further detail, and some of them are kind of open, and they're kind of very key to some of our decisions, like the tools that we use, etc. So the first resolved one, problems are detected, but sometimes too late. We've noticed with a typical CI flow, if you're just testing when you've pushed a change to your main line, that goes off, gets tested, tests can take, depending on the product, hours, and then you get notified at the end someone's broken it. And then you've got to go back and fix. You've got to push a new change to fix your kind of mainline branch. And we found that that's sometimes too late. So I'll cover that, what we've looked at for that. Maintenance and diverging projects. Because we work on lots of different projects, they're all managed by different people. The development teams are different, but sometimes we do switch developers between projects. But if the CI is separate for each project, we find that it kind of diverges off in kind of different configurations, and so things aren't done in the same way, which isn't ideal. So we've put a few things in place for that as well. And thirdly, performance testing. I mentioned our product, where we've got kind of algorithmic performance. We've kind of implemented some jobs for tracking that and things that help us kind of improve our algorithm. And open challenges. So because we're using free and open source tools, a lot of the features come from plugins. but we tend to find that a lot of them are out of date or buggy, and it's difficult to get them working. I know that a couple of our core plugins that we use, we're not actually using kind of released code. So people have made changes, the changes are there, but they're not formally released. So we've had to build them manually and put them into our CI. And there's also ones where people have submitted pull requests on GitHub, and we've had to manually patch those and bring them in. So it's not ideal, and that's a problem that we have, but that's probably a problem that kind of, because we've gone down the open source free tool route. And Jono mentioned the kind of other open challenge is convincing clients of the benefits. Not all clients kind of understand the benefits of CI. Obviously, we have some clients that don't understand the benefits of version control, so that's an even harder sell. But yeah, that's a difficult task that kind of we have, and we'd be interested to know if anyone can help us with that. So first of all, bringing CI into the loop. So this is where I said that sometimes CI detects problems too late. So a typical feature development, ideally a typical feature development wouldn't have broken CI tests, but sometimes they do. So we have here kind of, you have development, you have a peer review stage, you have a commit to your main line, and then your CI kicks in. Your CI tests it, and then it reports there's something been broken. And then you've got to go through a cycle of fixing this, again peer review, commit, and then the CI testing again. And during that period, you've got a broken kind of mainline branch. And any other developer could have branched off that, could be start using it, and that's not ideal. So, you know, during this feature development where someone has kind of broken it, we have 2 peer reviews created. You can probably bake them into one peer review request, but I think typically we do separate ones per commit. So as soon as something is committed automatically gets closed. You've had 2 pushes to mainline, one to break it, one to fix it again, and then you've got mainline broken for a period of time. So what we've done with our tools is we've brought CI into the loop of this kind of development. So we have, again, the development stage, and then as soon as it goes for peer review, our CI tools pick up the patch. So this is kind of pre-commit. It brings down the patch, it patches the main line, it runs the testing in parallel with the peer review. Because typically peer review can take time, like the actual review process might be fairly quick, but getting a developer to switch, like context switch from one task to a peer review task, you know, takes time. So it might be later that day, it might be the next day. And CI testing also takes time. There's a lot of tests to run in some products, so that can take hours. So running them in parallel is a lot more efficient. So again, for this feature development where we've had development, the CI testing in this case has found an error, you fix it in the review request, you do another cycle of review and CI testing, and then you do a single commit. And that means you haven't had any broken mainline. It's a lot sooner to get the feature delivered. And yeah, it's for the same feature that we've kind of developed in this way. We've just had the one review request, one push, and no broken mainline. And this means that, you know, it's a lot smoother. Your history is not of implement a feature, fix feature, implement feature, fix feature. So it's generally just implement. Yes?
So you say you don't have a broken mainline. So what version of code is the CI system testing? Is it on a branch or?
No, so we do kind of pre-commit branches. So you could have a local branch, and then you just create a patch, and that goes to your review request, and then the CI pulls that patch, patches the main line, right. Doesn't do any commits, it's just kind of local, and then it tests on that. So it's testing the changes that are going to get pushed. Yeah.
CI system instead.
Yeah. Yeah, well, we submit it to our peer review tool, and the CI system takes care of the rest. So in the peer review tool, it just looks like another reviewer. So the CI system is just another reviewer, basically. So CI maintenance, again, because we have lots of different projects running, we've got lots of different CI systems, and we want to kind of keep them all similar. So what we've done is defined a set of job templates, and these are kind of, at the moment we've got kind of got a lot of software templates, and these are for kind of running different static analysis tools, different builds, different unit test frameworks, and the template kind of encompasses it all. And what you can do is just simply bring those into your new project when you deploy a new server, customize, and then you've got a similar framework across multiple different projects. So when you've got developers that are switching across projects, they're already familiar with the system. And also we have job sharing. So here I've got a diagram that shows basically what we call kind of trigger jobs, and then our core build job. Now the reason we have this is so that if we needed to add a new stage into our core build job, we just add it in the one place. So say we've got a new build artifact we need to add in there, we just add it there. If we've got a new analysis tool to do, we just add it there, and then that's picked up by all the trigger jobs. So the focus of the trigger jobs is basically get the code changes you want to test and then offload it to the core build job. So you've got typical version control jobs, which is just build mainline, so when a change goes onto there, a custom kind of build commit if you wanted to test outside of your review, and kind of build a tag for a release. And then you've got peer review, build patch, so when you submit a review, it gets the patch, gets mainline, and then builds the core build job. And then we've got this kind of performance branch as well, which is I'll cover in a bit more detail in the next slide. And then for maintenance, we've also got a revision control. Now we've been bitten before by having a CI server fail, and all our jobs weren't backed up, so we had to recover them. So now all CI jobs, the configurations are in revision control. Now these, at the moment, we just have it so when anyone makes a configuration change, it automatically pushes to a separate repository. So a CI server has its own repository just for its configuration. We want to extend this so that our CI jobs are adjacent to the code, so in the same repository. And then the idea of this is it allows us to, when we submit a patch for kind of a new build artifact or an application or something, we can also submit the patch at the same time to the CI job. So when review board picks up the patch, when the patch is in review board, the CI server picks up the patch and it'll actually add the extra stage to the job that it runs, and it's purely for that patch. So this isn't changing the job that mainline is run on, it's just for that patch, and then as soon as you commit it, that changes it for everything. Without that, we've had to kind of add a review request, and then we push the change, and that adds the extra build artifact, and then we have to manually go back to the CI tool, add the build step, and it's a bit disjointed. So ideally, that would be all baked into revision control. But that's something we're working towards, and hopefully we'll achieve at some point.
Steve, so for products that have hardware components to them, and the hardware is changing, how do you track those changes with your CI maintenance system? So you develop a software for specific hardware.
Yeah.
FPGA, PCB, whatever, and it changes. So it maybe moves from revision 0.
Oh, so you have different targets?
Sorry?
Different targets,
Yes.
do you mean? I mean, generally, if you're still supporting the old target, you would just have a separate build process. So you build for one target, and then you also build for the other, and you kind of test both of them. If you're no longer interested in supporting the old target, you just replace it. Does that answer the question?
Yeah.
And so finally, the thing that we've looked at is performance testing. So I mentioned our product that kind of has performance metrics coming out of it. And so we've put these into our CI tools, and here, the top chart, we've basically got it tracking the mainline algorithm performance. You can see the commits along the bottom. The scores we want to be low. Obviously, you can see we introduced something that wasn't very good, and it jumped very high, kind of maintained roughly that level, and then we brought it back down. But generally, you see the trend is we are improving the algorithm, and this is useful because it tells us kind of over time how we're performing, and we can easily isolate single commits where it kind of jumped the wrong way.
In terms of the metric, sorry, which metric are you monitoring there? Is that speed and performance in terms of?
No, this is so. It's very much a custom metric. It's custom to our kind of algorithm. It's kind of we have without going into too much detail of the product, we have a value that we need to achieve. We have an algorithm that tries to get to that value. The score is the distance away from that. So if we ideally we'd be at 0, but we're not quite there yet. And so we've extended this to actually performing the performance test on development branches. So what we have is we can quickly create a branch just from your mainline, and you can tune any number of algorithm parameters, and you just tune them for each commit. So if you've got kind of a constant parameter, you can just say test a value of 1, commit, test a value of 2, and you can quickly set that up in sort of 5-10 minutes. And then we have these that are kind of run and scheduled overnight and give you a performance chart, so you can work out, well, which of these values is the best one. And obviously on this chart here, the very left-hand side is the mainline branch, so we didn't make any performance gains, so we probably dropped that feature.
Steve, sorry, when you said about tweaking the value of the variable to figure out which one's the best value, and you said it runs overnight, can you get it to automatically tweak those values?
At the moment, no. It's a manual process, so we would just commit. Yeah. So it's this is operating on Git, so it's really quick just to do loads of commits and then push a massive batch of them, and then just let it go.
You get it just sort of stacked, so the builds are kind of stacked, so they run sequentially.
Yes, you can. We do run multiple in parallel, and we can have multiple branches running at the same time. Because they take up a lot of resource to run the performance tests, we only run them overnight, and we have a scheduler built that kind of looks at all the branches that need to be tested, and it will keep running through all the commits until it hits sort of 8 o'clock in the morning, and then it will stop. So developers then have use of the machine, and then it will just resume the next night. So as long as you haven't kind of batched up thousands of tests, it kind of eventually gets there.
If you're running lots of jobs in parallel, you have to be careful they don't kind of interact. So if you had 2 jobs running on the same server, obviously the performance would suffer, and you see a drop.
Yeah, so we're not measuring, in this case, we're not kind of measuring performance in terms of speed of how things operate. It's purely how well is the algorithm performing to give us the right value.
Yes, it's
So
not CPU limited.
no. Obviously, if you're running loads, then that is going to be an issue. Yeah, that's a summary of kind of where we are at ITDev. We've had some questions. Is there any more?
So if you wanted to define CI from your perspective, what would you say CI is? How would you define it rather than using continuous and integrated?
Without saying those 2 words.
That's a difficult one. I mean, I guess the way we're using it is just testing, checking that everything is working against our tests. We're not integrating with hardware. We're not kind of bringing multiple things together. It's just ensuring we maintain quality across kind of all the changes that we're doing. Anything else?
No? Okay, thanks, Steve.